Hello friends, this is Computing from Scratch and welcome again to my course on digital logic. So far we have learned binary to decimal conversion, addition and multiplication in binary, as well as the representation of negative and fractional numbers in binary. As far as binary subtraction is concerned, we would rather perform binary addition where we 2's complement the number to be subtracted. We would like to do all sorts of computing with binary numbers because computers work with binary only. So, in order to do that, we will write some program which will typically read some input and write some output. And it might write it on the screen or in a file. Just using numbers, computers can do a lot. But input and output can come in other formats than just numbers. The input can be an English paragraph, a PNG image, or a video, or even an MP3 song. A video is composed of an audio and a set of frames, meaning images. Images are typically in RGB format, meaning red, green, and blue. It has 3 channels. Each channel is a 2-dimensional matrix. So here, each color image is formed from 3 sets of 2-dimensional matrices called channels. If you zoom in this picture, you will be able to see the pixelations. Here's a little Python code that takes the image that I painted earlier called paint1 and takes its red channel, the green channel, the blue channel and reverses the order and makes paint2. So we can see this is the original picture, paint1, and then it gets reversed, and this is the reversed picture. If we add the channels in the opposite order, first blue, then green, and then red, then what we are getting is an opposite. See, your green is preserved because the opposite green is sitting in the middle, so the opposite of green is green only, and you can see the blue birds have become red and the red tree trunk has become blue, and the cyan river has become an yellow river. Thank you. Let me give a brief overview of the code written here. The code here is written in interactive Python in a Jupyter notebook. The library used here is OpenCV, imported by cv2 command. It reads an image with imread and writes the image with imwrite. Every image in Python can be represented as a matrix. The colon operator here means that all the values are taken. So here the image's shape can be found by img.shape. It is a 300 by 400 image having 3 channels. So when I do that colon operator here, that means all 300 images in all 300 rows have been selected, and then another column means that all 400 columns have been selected. 0 means the red channel has been selected, 1 means the green channel has been selected, and 2 means the blue channel has been selected. And when I merge it by img : 2, comma img : 1 and img : 0, it means that when these 3 channels got merged together, the blue channel came first. The blue channel took the place of the red channel. So the blue channel will be treated as the red channel and the red channel will be treated as the blue channel, hence the image comes as an inverted image. As you can see, I took the liberty to print some of the values from 90 to 100 rows, 140 to 50 columns of all the channels. You can see that you get a value like 255, 255, 255 means total white here, 0 to 55, 102 means a mixture of green and blue. There is no red, red is 0 here. So what does this example show us? This example shows us that any image, a colored image, can be represented by three numbers. Better to say, any pixel in a color image can be represented by three numbers, one representing the pixel's red channel, second representing the pixel's green channel, and the third representing the pixel's blue channel. And when we take all the values of all the pixels in the image, the matrix that we get is the representation of the image itself. So now when we look at the single pixel, one channel, we can see the values range from 0 to 255, and any number between 0 and 255 can be represented by a unsigned 8-bit number. So if we have a binary number, 8-bit binary number that is unsigned, we can represent one channel of a pixel using that 8-bit binary number, and we can represent a colored pixel using three 8-bit binary numbers. And when we combine this 24-bit binary number for all the pixels in the image, we can get the binary representation of the image. Thank you friends. Please press a like if you like the video, and subscribe the channel if you want other people to watch the video as well. Goodbye. See you again in the next video.